Sit back. If you're watching this on your phone, go full screen. If you're at your computer, close the other tabs. Give yourself permission to fully immerse in what you're about to hear. And if you enjoy content that goes deep, content that doesn't rush, doesn't simplify, doesn't treat you like you need information in bite-sized pieces, subscribe. Because what you're about to experience is not a quick explainer. It's a journey into one of the most misunderstood systems in the human body. Today, we're going to explore the human fear system. Not with opinions, not with motivational phrases, not with life coaches telling you to just get over it. We're going to explore with facts. Hard, neurological, evolutionary, psychological facts. Facts that most humans never learn. Facts that, once understood, will change the way you experience fear forever. Because here's the thing, fear is not just an emotion. It's not something that happens to you randomly. Fear is a system, a highly sophisticated, ancient, deeply wired survival system that has been sculpted by millions of years of evolution. And that system is still running inside you right now, in this moment, even though you're probably sitting somewhere safe. Fear controls your decisions. It controls what you think about. It controls what you remember. It even controls what you imagine. And most people go their entire lives never understanding why they feel afraid when there's no danger. Why their heart races when they're about to speak in public. Why they wake up at 3 a.m. with anxiety about things that haven't happened. Why a thought, just a thought, can make their stomach drop. By the end of this, you won't just know what fear is. You'll understand why it exists, how it hijacks your mind, and why your brain treats imagined danger exactly the same as real danger. You'll understand why you feel fear, even when you're completely safe. So let's begin. Fact 1. The amygdala responds before you're consciously aware. The amygdala is a small, almond-shaped cluster of neurons buried deep in the temporal lobe of your brain. It is ancient. It exists in nearly every vertebrate species. And it has one primary job: detect threat and initiate survival response. Here's what makes the amygdala extraordinary. It processes sensory information before your conscious mind even knows what's happening. When you see something, a shadow, a face, a sudden movement, that visual information travels through your eyes to your thalamus, which acts as a relay station. From there, the information splits into two pathways. The first pathway is slow. It goes to your visual cortex, where the image is analyzed in detail. Your brain carefully interprets what you're seeing, considers context, applies logic. This pathway takes time. It's deliberate. It's conscious. The second pathway is fast. It bypasses the cortex entirely and goes straight to the amygdala. This pathway is crude. It doesn't care about details. It only cares about one thing. Is this a threat? And it makes that judgment in roughly 12 milliseconds. 12. Before you've even consciously registered what you're looking at, your amygdala has already decided whether to be afraid. This is why you can feel your heart start to race before you even know why. You might be walking down a dark street, and suddenly your body tenses. Your breathing changes. Your pupils dilate. And only a moment later does your conscious mind catch up and realize, oh, there's someone behind me. But your amygdala knew first. It always knows first. This system evolved because speed was survival. If you're a human ancestor walking through tall grass and you see something that might be a lion, you don't have time to carefully analyze whether it's actually a lion or just a pile of leaves. You need to react now. The ones who stop to think carefully often didn't survive long enough to pass on their genes. The ones who flinched first, who ran first, who felt fear first, they lived. And you are descended from them. But here's the problem. That same system is still running in your modern brain. And it cannot tell the difference between a lion in the grass and an email from your boss. It cannot tell the difference between a physical predator and a social threat. It treats them the same, because to your amygdala, danger is danger. Fact 2. Fear activates faster than rational thought. Your prefrontal cortex, the part of your brain responsible for logic, reasoning, planning, and self-control, is slow. It's powerful, yes. It's what makes you human. But it's slow. The prefrontal cortex is located at the very front of your brain, just behind your forehead. It's the most recently evolved part of the human brain. It's what allows you to think about the future, to weigh options, to override impulses. It's what lets you say, I'm angry, but I'm not going to yell, or I'm scared, but I'm going to do this anyway. But the prefrontal cortex takes time to activate. It requires conscious effort. It requires you to pause, to breathe, to think. And in moments of fear, you don't have that time. When your amygdala detects a threat, it doesn't wait for permission from the prefrontal cortex. It doesn't send a polite memo saying, "Excuse me, I think we might be in danger. Could you please review this and let me know what you think?" No, it acts immediately. It floods your body with stress hormones, adrenaline, cortisol, norepinephrine, and it triggers the fight or flight response. This is why, in moments of intense fear, you lose access to your rational mind. You've probably experienced this. Someone says something that triggers you, and suddenly you're yelling, and later you think, why did I say that? That's not even what I meant. Or you're about to give a presentation, and your mind goes blank, and you can't remember the words you practiced 100 times. That's not a failure of willpower. That's not weakness. That's your amygdala overriding your prefrontal cortex. Because in the hierarchy of survival, fear wins. Logic loses. Neurologically, this happens through a process called amygdala hijack, a term coined by psychologist Daniel Goleman. When the amygdala perceives a threat, it essentially takes over the brain's control center. It suppresses activity in the prefrontal cortex. It narrows your focus. It shuts down everything that isn't immediately relevant to survival. Creativity? Gone. Long-term planning? Irrelevant. Empathy? Not now. All that matters is survive this moment. And this made perfect sense for most of human history. If you're being chased by a predator, you don't need to be creative. You don't need to plan for next week. You need to run. Now. But in the modern world, most threats are not predators. Most threats are psychological, social, imaginary. And yet, your brain still responds the same way. Your amygdala still hijacks your prefrontal cortex. And you still feel that same primal panic, even when the danger is just a difficult conversation, or a deadline, or a thought about the future. Fact 3. The brain cannot distinguish between real and imagined threats. This is one of the most important facts about fear, and it explains why anxiety exists. Your brain is a prediction machine. It doesn't just respond to what's happening right now. It's constantly scanning the environment, analyzing patterns, and predicting what might happen next. And when it predicts danger, even hypothetical danger, it treats that prediction as real. Neuroscientist Lisa Feldman Barrett has spent decades studying how the brain constructs emotions, and her research reveals something critical. Your brain doesn't wait for danger to be confirmed before responding. It responds to the possibility of danger. And it does this because, from an evolutionary perspective, false alarms are cheap. Missing a real threat is fatal. Imagine you're an early human. You hear a rustling in the bushes. There are two possibilities. 1, it's a predator. 2, it's just the wind. If you assume it's the wind and you're wrong, you die. If you assume it's a predator and you're wrong, you waste a little energy running away. Natural selection strongly favored humans who overestimated threats, who felt fear even when the danger wasn't certain. So your brain is wired to err on the side of caution. And that means it will generate fear in response to things that are merely possible. Things that haven't happened yet. Things that might never happen. This is why you can lie in bed at night, completely safe, and feel your heart pounding because you're thinking about a conversation you have to have tomorrow. There's no danger in that moment. No predator. No physical threat. But your amygdala doesn't care. It has detected a threat in your thoughts, and it has activated the fear response. And here's the truly fascinating part. When your brain generates fear in response to an imagined threat, it doesn't label it as imaginary. It feels exactly the same as real fear. Your heart races. Your palms sweat. Your breathing gets shallow. Your muscles tense. Because the physiological response to fear is the same whether the danger is real or imagined. This is not a design flaw. This is a survival feature. Because in the wild, by the time you know for certain that the danger is real, it's often too late. So your brain treats uncertainty as danger, and it makes you feel afraid to protect you. But in the modern world, where most dangers are not physical, this system backfires. You end up feeling afraid of things that cannot hurt you. You feel afraid of judgment, of failure, of rejection, of uncertainty itself, and your brain responds to all of it as if your life is in danger. Fact 4. Fear is physically felt because it prepares the body for action. Fear is not just a mental experience. It is deeply, intensely physical. And the reason for this is simple. Fear evolved to prepare your body for survival action. When your amygdala detects a threat, it immediately sends signals to the hypothalamus, which acts as a command center. The hypothalamus activates the sympathetic nervous system, which is responsible for the body's acute stress response. Within seconds, a cascade of physiological changes occurs. Your adrenal glands release adrenaline into your bloodstream. Adrenaline increases your heart rate, which pumps more blood to your muscles. Your breathing becomes faster and shallower, increasing oxygen intake. Your liver releases stored glucose into your blood, providing immediate energy. Your pupils dilate, improving vision. Your muscles tense, preparing to fight or flee. Your digestion slows or stops entirely. Your body doesn't waste energy on digestion when survival is at stake. Even your blood changes. It becomes stickier, more prone to clotting in case you're injured. Your immune system temporarily suppresses non-essential functions to conserve resources. All of this happens automatically. You don't choose it. You can't stop it. It's a hardwired survival program that has been refined over millions of years. And this is why fear feels the way it does. That tightness in your chest, that's your heart rate increasing and your breathing changing. That sinking feeling in your stomach, that's blood being redirected away from your digestive system to your muscles. Those shaky hands, that's adrenaline. That tunnel vision, that's your brain narrowing your focus to the threat. Every single physical symptom of fear exists for a reason. And in a life or death situation, these changes are incredibly useful. They make you faster, stronger, more alert. They give you the best possible chance of survival. But when you're sitting in a meeting, or lying in bed, or scrolling through social media, these same physical responses are not helpful. They're uncomfortable. They're distressing. And they can make you feel like something is terribly wrong, even when there's no actual danger. This is why people with anxiety disorders often describe physical symptoms, chest pain, dizziness, nausea, and fear they're having a heart attack or dying. They're not imagining it. The physical sensations are real. The danger is not. Fact 5. The freeze response is a third, often forgotten survival mechanism. Most people have heard of fight or flight. It's become a cultural shorthand for the fear response. But there's a third response that's just as important and often more common: freeze. Freezing is not the same as being paralyzed by indecision. It's a specific neurological response that occurs when the brain determines that neither fighting nor fleeing will work. When an animal, including a human, perceives a threat but cannot escape and cannot win a fight, the nervous system activates the freeze response. This involves the dorsal vagal complex, a part of the parasympathetic nervous system that essentially shuts the body down. Heart rate drops. Breathing becomes very shallow. The person or animal becomes very still, almost catatonic. Muscle tone decreases. In extreme cases, the person may faint. This response evolved for specific survival scenarios. If you're being attacked by a predator and you can't fight it and you can't outrun it, your best chance of survival might be to play dead. Many predators lose interest in prey that stops moving. Some predators are even wired to respond primarily to movement. If you freeze, you might become invisible. The freeze response also reduces pain. When the body floods with endogenous opioids during a freeze state, it creates a kind of numbing effect. This is why some people report feeling detached or unreal during traumatic events. It's a neurological mercy, the body protecting itself from overwhelming pain. But in the modern world, the freeze response often occurs in situations where it's not helpful. A person might freeze during a job interview, during a confrontation, during public speaking, During a test, their mind goes blank. They can't think. They can't speak. They feel stuck. And afterward, they often judge themselves harshly. Why didn't I just say something? Why did I just stand there? What's wrong with me? Nothing is wrong. Their nervous system made a split-second calculation that neither fighting, confrontation, nor fleeing, escape, was possible, and it activated the oldest, deepest survival response: freeze. This is especially common in people who experience trauma, particularly in childhood. If you grew up in an environment where you couldn't fight back and you couldn't run away, an abusive home, for example, your nervous system learned that freezing was the safest option. And that pattern can persist into adulthood, activating in situations that aren't actually dangerous but feel psychologically similar. Understanding this can be profoundly compassionate. Freezing is not weakness. It's not cowardice. It's survival. Fact 6. Fear and memory are neurologically bonded. Your brain has an extraordinary ability to remember things that scared you. This is not an accident. This is one of the most crucial survival mechanisms in the animal kingdom. The connection between fear and memory involves a structure called the hippocampus, which sits right next to the amygdala. The hippocampus is responsible for forming and retrieving memories, especially memories of events and contexts. When the amygdala is activated by fear, it sends signals to the hippocampus that essentially say, "Remember this. This is important." The stress hormones released during fear, particularly adrenaline and cortisol, enhance memory consolidation. They make the memory stronger, more vivid, more durable. This is why you can remember, in perfect detail, the moment you almost got into a car accident, or the time you were bitten by a dog, or the day you were humiliated in front of a group. Your brain has encoded those memories with extraordinary clarity because they involved fear. And that clarity serves a purpose, so you can avoid similar situations in the future. If your ancestor ate a certain berry and became violently ill, their brain needed to remember exactly what that berry looked like, so they'd never eat it again. If your ancestor was attacked at a particular watering hole, they needed to remember that location. Fear makes memories stick, but this system also creates problems. Because traumatic memories encoded during intense fear, don't fade the way normal memories do. They remain vivid, intrusive, easily triggered. A person who is in a car accident might feel a surge of fear every time they hear brakes squeal, even years later. A person who is attacked might feel terror at the sight of someone who vaguely resembles their attacker. This is the basis of post-traumatic stress disorder, PTSD. The memory of the traumatic event remains so strongly encoded and so tightly linked to the fear response that even small reminders can trigger the full physiological reaction. The person isn't choosing to feel afraid. Their amygdala has learned to associate certain cues with danger, and it reacts automatically. And here's something even more complex. The brain can form fear memories even when you're not consciously aware of what you're afraid of. Researcher Joseph Ledoux demonstrated this with a phenomenon called fear conditioning. In experiments, a neutral stimulus, like a tone, is paired with an unpleasant stimulus, like a mild shock. After a few pairings, the tone alone triggers a fear response, even if the person or animal can't consciously explain why. This means you could be afraid of things without knowing why. You might feel anxious in certain situations and have no idea where that anxiety comes from. It might be rooted in a memory you don't consciously recall. A smell, a sound, a feeling, something your amygdala remembers, even if you don't. Fact 7. The amygdala learns fear far more easily than it unlearns it. Your brain is asymmetrically wired when it comes to fear. It's much easier to learn fear than to unlearn it. If you have a single frightening experience with something, let's say you get stung by a bee, your amygdala can form a fear association immediately. One trial learning. From that moment on, the sight or sound of a bee might trigger fear. Your brain has learned bees equals danger. But unlearning that fear is much slower. Even if you have dozens of neutral or positive experiences with bees afterward, that original fear association doesn't just disappear. It fades, yes, but it remains encoded in your neural circuitry. This is called extinction in psychological terms, but it's a misleading word because the fear isn't actually extinguished. It's suppressed. The prefrontal cortex learns to inhibit the amygdala's response. You learn to override the fear, but the original fear memory is still there, dormant, waiting. This is why phobias are so hard to overcome. Why someone who was bitten by a dog as a child can still feel afraid of dogs as an adult, even after years of safe interactions. Why a person who had a panic attack on an airplane might avoid flying for decades. From an evolutionary perspective, this makes sense. If you narrowly survive an encounter with a predator, your brain needs to ensure you never forget it. False negatives, failing to recognize danger, are much more costly than false positives. So the brain holds on to fear memories tightly. But in the modern world, this creates suffering. People become trapped by fears that are no longer relevant. Fears that were once adaptive but are now limiting. And because the brain doesn't easily let go of fear, overcoming it requires deliberate, sustained effort. Therapy, exposure, cognitive restructuring. You have to slowly teach your prefrontal cortex to regulate your amygdala. To say, I know you think this is dangerous, but it's not. And even then, the fear can return. Stress, sleep deprivation, or a triggering event can reactivate old fears. The neural pathways never fully disappear. They just become less traveled. Fact 8. Darkness triggers fear because of evolutionary history. The fear of darkness is nearly universal in humans, especially in children. And it's not cultural. It's not learned. It's genetic. For millions of years, humans were prey. We were not apex predators. We were vulnerable, especially at night. We don't have night vision. We don't have sharp claws or fangs. In the dark, we are effectively blind, slow, and defenseless. And for our ancestors, darkness was when predators hunted. Nocturnal predators, big cats, hyenas, snakes, were a constant threat. Humans who feared the dark, who stayed close to fire, who remained alert and cautious, were more likely to survive. Those who wandered carelessly into the darkness often didn't live to reproduce. So the fear of darkness became hardwired. It's not something you need to learn. It's already there when you're born. Watch a baby's face when the lights suddenly go out. Their startle response activates immediately. They don't need to be taught that darkness is dangerous. Their brain already knows. Even as adults, when we're in complete darkness, our amygdala activity increases. Our heart rate rises. Our breathing changes. We become hyperalert, and our imagination fills the void with threats. This is because the brain hates uncertainty, and darkness is pure uncertainty. You can't see. You can't assess. You can't verify whether you're safe. So your brain assumes you're not. This is why people report feeling watched in the dark. Why shadows seem threatening. Why every creak and rustle becomes amplified. Your brain is in threat detection mode, and it's interpreting ambiguous sensory information as potential danger. Interestingly, this fear can be partially overridden by context. If you're in your own bedroom, in a locked house, your prefrontal cortex can usually calm your amygdala. You know you're safe. But if you're in an unfamiliar place or outside or alone, that reassurance is weaker. The amygdala's voice is louder. And for some people, particularly those with anxiety or trauma histories, the fear of darkness remains intense throughout life because their threat detection system is hypersensitive. Their amygdala is louder, and their prefrontal cortex has a harder time overriding it. Fact 9. Heights trigger fear because falls were lethal. The fear of heights, acrophobia, is another innate, evolved fear. And it exists for an obvious reason. Throughout human history, falling from a significant height was almost always fatal or severely injuring. Unlike some animals, humans don't have wings. We don't have the ability to cushion falls. We can't cling to trees with prehensile tails. When we fall hard, and our bodies are surprisingly fragile. A fall from even 10 or 15 feet can cause broken bones, head trauma, internal injuries. So natural selection favored individuals who felt fear when they looked down from a high place. That fear made them cautious. It made them slow down. It made them think twice before stepping too close to the edge. Interestingly, infants show a rudimentary awareness of depth very early. In the famous visual cliff experiment, babies as young as 6 months old would refuse to crawl over a glass surface that appeared to drop off, even though the glass was solid. They could perceive depth, and they instinctively avoided the apparent drop. This isn't taught. It's built in. But the fear of heights is also modulated by experience. People who grow up in mountainous regions, or who work in construction, or who climb regularly often have less intense fear responses to heights. Their prefrontal cortex has learned to regulate the amygdala's alarm. They've had repeated experiences of being at heights and being safe, and their brain has adjusted its threat assessment. But even then, the fear isn't gone. Put that same experienced climber on an unstable platform, and their fear response will return. Because the amygdala is always monitoring, always assessing, always ready to sound the alarm. And for people with acrophobia, a clinical debilitating fear of heights, the response is overwhelming. They might feel dizzy, nauseous, panicked, even when they're just a few feet off the ground. Their amygdala has become hypersensitive to height cues. And no amount of logic or reassurance can immediately override that response. This is the challenge with all evolutionary fears. They made sense in the environment where they evolved, but they don't always match the actual level of danger in the modern world. Fact 10. Sudden movements trigger immediate fear responses. Your visual system is wired to detect movement before it detects anything else. And when something moves suddenly in your peripheral vision, your amygdala activates before you even turn your head to look. This is because, for most of human evolution, sudden movement meant potential threat. Predators move. Attacks come quickly. If something in your environment suddenly changes position, your brain needs to assess it immediately. This is why you can be sitting calmly, and a bird suddenly flies past your window, and you flinch. You weren't consciously afraid. You weren't thinking about danger. But your visual system detected the movement, sent a signal to your amygdala, and your body reacted. The startle response, that full body jolt you feel when something surprises you, is one of the fastest reflexes in the human body. It involves a direct pathway from the sensory organs to the amygdala to the motor system. It bypasses conscious thought entirely. And this response is incredibly hard to suppress. Even if you know something is coming, even if someone tells you, "I'm about to clap my hands loudly," you'll still flinch when they do it. Because the startle response is precognitive. It happens before your conscious mind can intervene. This is also why horror movies use jump scares. They exploit this hardwired response. A sudden loud noise, a sudden movement on screen, your amygdala reacts, and you feel fear, even though you consciously know you're safe, sitting in a theater or on your couch. In everyday life, this sensitivity to movement can cause unnecessary fear. A shadow moving across the wall, a person walking up behind you, a dog running toward you. Your brain interprets all of these as potential threats, at least initially, because movement equals change equals potential danger. And for people with hypervigilance, common in anxiety disorders and PTSD, this response is even more pronounced. Their threat detection system is always on high alert. They notice every movement, every sound, every change, and each one triggers a microdose of fear, even when there's no actual danger. Over time, this constant activation is exhausting. It's like living with a car alarm that goes off at every passing breeze. The evolution of fear. Fact 11. Humans evolved as prey, not predators. This is a humbling truth. For most of human evolutionary history, we were not at the top of the food chain. We were prey. When you look at modern humans, it's easy to forget this. We have technology. We have weapons. We have cities. We dominate the planet. But for millions of years, our ancestors were small, relatively weak primates living in an environment filled with creatures that could kill them. Big cats, hyenas, crocodiles, large snakes, birds of prey. All of these posed lethal threats. And unlike prey animals that evolved speed, like gazelles, or size, like elephants, or armor, like rhinos, humans evolved something different: intelligence and social cooperation. But intelligence takes time to develop, and social cooperation only works if you survive long enough to form groups. So in the meantime, fear was the primary defense. Our ancestors who were cautious, who were afraid, who stayed alert, they survived. Those who were bold, who were careless, who wandered away from the group, they often didn't. This is why humans have such a sensitive fear system. We didn't evolve to be fearless. We evolved to be fearful. And that fear kept us alive long enough to develop the intelligence and social structures that eventually allowed us to become apex predators. But your brain doesn't know that you're at the top of the food chain now. It's still running the same software that was designed for a world where you were prey. And that's why you still feel fear in situations where there's no physical threat. Your amygdala is still scanning for predators, even when you're sitting in a climate-controlled office building, surrounded by walls and locks and security systems. Fact 12. Predator recognition patterns are hardwired. Your brain has built-in templates for recognizing predators. This is called prepared learning, and it explains why certain fears are nearly universal and why they develop so easily. Snakes, spiders, angry faces, sharp teeth, eyes staring directly at you. These stimuli trigger fear responses much more easily than other stimuli, even if you've never had a negative experience with them. A child who has never seen a snake can still react with fear the first time they encounter one. An adult who has never been bitten by a spider can still feel intense fear at the sight of one. Why? Because these were evolutionarily relevant threats. For millions of years, venomous snakes and spiders killed humans, and natural selection favored individuals whose brains could quickly recognize and fear these threats. Interestingly, you don't develop the same automatic fear of things that are statistically much more dangerous. Cars kill far more people than snakes. Electrical outlets are far more dangerous than spiders. But people don't have an innate fear of cars or outlets, because those threats are new. They didn't exist during the millions of years when your brain was evolving. So your brain has no built-in template for fearing them. This is called the evolutionary mismatch. Your brain is ancient. Your environment is modern, and the two don't always align. This is also why media and culture can't easily create new fears from scratch. You can tell someone that a particular food is dangerous, and they might intellectually understand, but they won't feel the same visceral fear they'd feel seeing a snake. Because the fear of snakes is hardwired. The fear of processed food is not. Fact 13. Facial recognition and threat detection are linked. Humans are extraordinarily good at recognizing faces, better than almost any other species. And this ability is deeply connected to the fear system. Your brain has a specialized region called the fusiform face area, FFA, that is dedicated entirely to processing faces. It activates whenever you see a face in a photo, on a screen, even in ambiguous patterns like clouds or toast. This is called pareidolia, and it happens because face recognition was so critical to survival. But it's not just about recognizing faces. It's about reading them. Specifically, reading them for signs of threat. An angry face, a face with direct eye contact, a face that's watching you. These activate the amygdala immediately, because in the social world of primates, facial expressions communicate intent. An angry face signals potential aggression. Direct eye contact can signal challenge or threat. This is why you can be scrolling through social media and suddenly feel a jolt of discomfort when you see a photo of someone staring directly at the camera with an angry expression. Your amygdala has detected a threat cue, even though it's just a picture, even though that person is nowhere near you. It's also why people with social anxiety often interpret neutral faces as hostile. Their amygdala is hypersensitive to potential social threat, so it errs on the side of caution and reads ambiguous expressions as negative. And this is deeply rooted in primate evolution. In many primate species, direct eye contact is a sign of aggression. Staring is a challenge. Looking away is submission. Humans have inherited this wiring. We're uncomfortable with prolonged eye contact, especially from strangers. It feels threatening. Understanding this can make social anxiety more compassionate. The person isn't being irrational. Their brain is doing exactly what it evolved to do: scan faces for signs of threat. The problem is that their amygdala is too sensitive. It's seeing threats that aren't there. Fact 14. Humans fear silence because it signals danger. Silence is unsettling, and there's a neurological reason for this. In nature, silence often means that predators are near. When a predator enters an area, prey animals stop making noise. Birds stop singing. Insects stop buzzing. The forest goes quiet. For early humans, this sudden silence was a warning signal. It meant something dangerous was nearby. So your brain evolved to become alert when things get too quiet. This is why silence feels uncomfortable. Why you might put on music or turn on the TV just for background noise. Why complete silence, especially in an unfamiliar place, can make you feel uneasy. Your amygdala interprets silence as absence of information. An absence of information is uncertain. An uncertainty is potential danger. This is also why sudden silence in a conversation feels awkward. Your brain is wired to expect auditory input, especially in social situations. When that input stops, it feels like something is wrong. In modern environments, we've largely eliminated natural silence. We live in a constant bath of noise, traffic, machines, electronics, voices. And when that noise suddenly stops, a power outage, a late night in an empty building, it can feel eerie, threatening, even though nothing has actually changed except the absence of sound. This also explains why people report feeling afraid in sensory deprivation environments. In a completely dark, completely silent space, the brain has no input. It can't assess. It can't orient. And in the absence of information, it assumes the worst. Fact 15. The fear of being watched is rooted in predator avoidance. Have you ever felt like someone was watching you, and you turn around, and someone was? This sensation, the feeling of being watched, is surprisingly common. And while there's no scientific evidence that humans have a literal sixth sense for detecting gaze, there is evidence that our brains are constantly monitoring the environment for signs of attention from others. This makes evolutionary sense. Being watched could mean several things, none of them good. It could mean a predator is stalking you. It could mean a rival is sizing you up. It could mean you're about to be attacked. So your brain evolved to be sensitive to cues that suggest you're being observed. Peripheral movement, the sense of someone behind you. Changes in the environment that might indicate another presence. And when your brain suspects you're being watched, it activates the same threat detection system. Your amygdala becomes more active. Your attention sharpens. You become more alert. This is also why people feel uncomfortable when someone stares at them. Even if the person isn't doing anything threatening, the act of sustained attention feels like a potential threat. Because in our evolutionary past, sustained attention often preceded aggression. Interestingly, this fear is modulated by context. If you're being watched by someone you trust, a friend, a family member, it doesn't trigger the same response. But if you're being watched by a stranger, especially in an isolated or unfamiliar environment, the discomfort is much stronger. This is the basis of social anxiety in many cases. The feeling of being observed, judged, evaluated. It taps into this ancient fear of being watched by potential threats. Fact 16. Enclosed spaces trigger fear because they limit escape. Claustrophobia, the fear of enclosed spaces, is incredibly common. And it's not arbitrary. It's rooted in a very practical survival concern, the need to escape. Throughout human evolution, being trapped was often fatal. If you were cornered by a predator, if you were caught in a collapsed cave, if you were stuck somewhere with no way out, your chances of survival plummeted. So the brain evolved to feel discomfort in situations where escape is difficult or impossible. Tight spaces, crowded rooms, locked doors, elevators, tunnels, MRI machines. When you're in these environments, your amygdala monitors your options. And when it determines that escape would be difficult, it sounds a low-level alarm. You might feel restless, tense. Your breathing might quicken. You might feel an urge to leave. This is your brain saying, This is not a safe position. We need to be somewhere with more options. For most people, this discomfort is mild and manageable. But for people with claustrophobia, the response is overwhelming. Panic, terror, a desperate need to get out. This often develops after a traumatic experience, being stuck in an elevator, being trapped in a small space as a child, being physically restrained. The amygdala forms a powerful fear memory, and afterward, any similar situation triggers the same intense response. And because the fear is about lack of control and inability to escape, reassurance often doesn't help. Telling someone with claustrophobia, "You're safe, nothing bad will happen," doesn't address the core fear. The fear isn't about what will happen. It's about what could happen and the inability to do anything about it. Fact 17. Unfamiliar environments increase fear sensitivity. Your brain feels safer in familiar environments. This is because familiarity means predictability, and predictability means you can anticipate danger. When you're in a place you know well, your home, your neighborhood, your workplace, your brain has a mental map. It knows what sounds are normal, what movements are expected, what's supposed to be there. And when something in that familiar environment changes, your brain notices immediately. This is called change detection, and it's a fundamental function of the amygdala. But in an unfamiliar environment, everything is new. Nothing is predictable. Your brain has no baseline, so it becomes hypervigilant. It treats every sound, every movement, every shadow as potentially significant. This is why you might feel anxious when traveling to a new place, why you sleep poorly the first night in a hotel, why you feel on edge walking through a neighborhood you don't know. Your amygdala is working overtime. It's trying to build a mental map, assess the level of threat, and determine what's normal. Until it completes that process, it assumes nothing is safe. This is also why people with anxiety often prefer routine. Routine means familiarity. Familiarity means safety. Breaking routine means entering the unknown. And the unknown is where threats hide. Interestingly, this fear of the unfamiliar extends to people, not just places. Humans are tribal by nature. We evolve in small groups where everyone knew everyone. Strangers were rare, and they were often dangerous, rival groups, potential threats. So your brain is wired to be cautious around unfamiliar people, to scan them for threat cues, to keep your distance until you've determined they're safe. This isn't prejudice in the moral sense. It's a survival mechanism. But in the modern world, where we're constantly surrounded by strangers, this mechanism can create chronic social anxiety, because your amygdala is constantly encountering unfamiliar people and treating each one as a potential threat. Imaginary fear and the anxiety paradox. Fact 18. Anxiety is fear of the future. Anxiety and fear are related, but they're not the same. Fear is a response to a present threat. Anxiety is a response to a possible future threat. When you're afraid, there's something specific you're afraid of right now. A dog is growling at you. You're standing on the edge of a cliff. Someone is yelling at you. But when you're anxious, there's no immediate threat. Instead, your brain is simulating possible future scenarios and responding to those simulations as if they're real. What if I fail the test? What if they don't like me? What if I lose my job? What if something bad happens? These are all future-oriented thoughts, and your amygdala responds to them the same way it responds to actual threats. It activates the fear response. Your heart races. Your stomach tightens. You feel dread, but there's nothing to fight, nothing to flee from. The threat exists only in your mind. This is the core of anxiety. It's fear without an object, fear without a present danger. And because there's no actual threat to resolve, the fear doesn't go away. It just lingers. Neuroscientist Joseph Ledoux describes anxiety as the price we pay for an ability to anticipate the future. Because the ability to imagine future scenarios is incredibly valuable. It allows you to plan, to prepare, to avoid danger before it happens. But the same mechanism that allows you to plan also allows you to worry. And if your threat detection system is hypersensitive, you end up imagining threats that are unlikely or impossible. and your brain responds to all of them. This is why anxiety can feel so exhausting. You're not just dealing with real problems. You're dealing with imagined problems, hypothetical problems, problems that might never happen, and your brain treats each one as urgent. Fact 19. Overthinking is a form of threat scanning. People who struggle with anxiety often describe their minds as always going. They can't shut off their thoughts. They lie awake at night, replaying conversations, imagining worst-case scenarios, analyzing everything that could go wrong. This isn't a character flaw. This is the brain's threat detection system working in overdrive. Overthinking is essentially mental scanning. Your brain is searching for potential threats. It's running simulations. It's trying to predict danger so you can avoid it. In a genuinely dangerous environment, this would be adaptive. If you're a human ancestor living in a world full of predators and hostile tribes, you need to think ahead. You need to imagine what could go wrong. You need a plan. But in the modern world, most dangers are not physical. And most situations don't require constant threat scanning. But the system doesn't know that. So it keeps running. And here's the problem. The more you think about potential threats, the more real they feel. Because each time you imagine a negative scenario, your amygdala responds. And each response reinforces the neural pathway. You're essentially training your brain to be more afraid. This is why people with anxiety often say, "I know it's irrational, but I can't stop thinking about it." Because the thoughts aren't voluntary. They're automatic. The brain is doing what it evolved to do: search for danger. And because the brain has no way to distinguish between real threats and imagined threats, it treats your anxious thoughts as real. And it keeps your body in a state of chronic stress. Fact 20. Uncertainty is interpreted as danger. The human brain hates uncertainty. And this makes evolutionary sense. In the wild, uncertainty is dangerous. If you don't know whether that rustling in the bushes is a predator or the wind, you need to assume the worst. If you don't know whether that berry is poisonous, you need to be cautious. If you don't know whether that stranger is friendly or hostile, you need to stay alert. Certainty means safety. Uncertainty means potential threat. So when you're faced with an uncertain situation, a medical test result you're waiting for, a job interview outcome, a relationship that feels unstable, your amygdala activates. It interprets the lack of information as danger. This is why waiting is so uncomfortable. Why people often say they'd rather have bad news than no news. Because bad news is certain. You know what you're dealing with. You can respond. But uncertainty leaves you in limbo. And your brain doesn't handle limbo well. This is also why people with anxiety often seek reassurance. They ask the same questions over and over. Are you sure? Will everything be okay? What if this happens? They're trying to eliminate uncertainty. They're trying to turn the unknown into the known. But reassurance only works temporarily, because the brain can always generate new uncertainties, new what-ifs, and each one triggers the same response. This is the trap of anxiety. You can't eliminate uncertainty. Life is inherently uncertain. The future is unknown. And as long as your brain interprets uncertainty as danger, you'll feel anxious. Fact 21. Catastrophic thinking is a survival strategy gone wrong. Catastrophic thinking, imagining the worst possible outcome, is a hallmark of anxiety. And while it feels irrational, it's actually a distorted version of a useful survival strategy. Throughout evolution, it was better to overestimate danger than to underestimate it. If you heard a sound in the bushes and assumed it was a predator when it was actually just the wind, you wasted a little energy running away. But if you assumed it was the wind when it was actually a predator, you died. So the brain evolved to err on the side of caution, to imagine the worst, to prepare for the worst. Catastrophic thinking is this tendency taken to an extreme. Instead of just considering the possibility of danger, the anxious brain becomes convinced that the worst outcome is the most likely outcome. If I give this presentation, I'll mess up and everyone will laugh at me, and I'll lose my job and I'll never find another one, and I'll end up homeless. This chain of reasoning feels real in the moment. Each step seems logical, but when you examine it, Each step is actually a huge leap. Each step assumes the worst possible outcome at every branch point. And the problem is that when you catastrophize, your brain responds to the catastrophe as if it's already happening. You feel the fear, the dread, the despair, even though nothing has actually gone wrong. This is especially common in people with generalized anxiety disorder, GAD. Their brains are constantly generating catastrophic predictions. And because the amygdala responds to predictions as if they're real, they live in a state of constant fear. Fact 22. The brain simulates threats to prepare for them. Your brain is constantly running simulations. It's imagining future scenarios, predicting outcomes, and preparing responses. This is called prospective cognition, and it's one of the most sophisticated functions of the human brain. When you imagine giving a presentation, your brain is simulating that experience. When you think about a difficult conversation you need to have, your brain is running through possible versions of that conversation. This allows you to prepare, to rehearse, to plan. But when the brain simulates a threatening scenario, it activates the same neural networks that would activate if the threat were real. Your amygdala responds. Your body responds. You feel fear. This is why visualization can be powerful. Athletes visualize successful performances, and their brains respond as if they're actually performing. The neural pathways get activated and strengthened. But the same mechanism works in reverse. If you spend time visualizing failure or danger or worst-case scenarios, your brain responds to those simulations. And you feel afraid. This is not a bug. It's a feature. By simulating threats, your brain is trying to prepare you. It's saying, here's what could go wrong. Let's be ready. But when you simulate threats constantly, when your brain is always imagining what could go wrong, you end up in a state of chronic fear, even though none of the threats are real. This is the paradox of anxiety. The brain is trying to protect you by preparing you for danger. But in doing so, it creates the very suffering it's trying to prevent. Fact 23. Worry feels productive, but usually isn't. People who worry often describe it as a way of being responsible. If I don't think about what could go wrong, something bad will happen. Worrying helps me prepare, and there's a kernel of truth there. Thinking through potential problems can be useful. Planning for contingencies is smart. But worry is different from planning. Planning is solution-focused. You identify a problem, consider options, make a decision, and take action. Worry is circular. You think about a problem, imagine all the ways it could go wrong, feel anxious, and then think about it some more. There's no resolution, no acción, just rumination. And yet, worry feels productive. It feels like you're doing something because your brain is active. You're thinking. You're engaged. But neuroscience research shows that worry doesn't actually improve outcomes. It doesn't make you more prepared. It doesn't prevent bad things from happening. What it does do is keep your amygdala activated. It keeps your body in a state of stress, and it exhausts your mental resources. Psychologist Thomas Borkovec studied worry extensively and found that it actually serves a function. It suppresses emotional processing. When you worry, when you think in words and hypotheticals, you're not feeling the deeper emotions underneath. The grief, the fear, the sadness. Worry is a form of avoidance. It keeps you in your head so you don't have to feel what's in your body. But the cost is high. Chronic worry leads to chronic stress, and chronic stress has profound effects on physical and mental health. Fact 24. The what-if loop is a cognitive trap. Anxiety often takes the form of what-if questions. What if I fail? What if they reject me? What if something goes wrong? What if I can't handle it? These questions feel important. They feel like your brain is trying to solve a problem, but they're actually a trap. Because what if questions have no answers? They're about the future, which is unknown. No matter how much you think about them, you can't resolve them. You can't know what will happen until it happens. But your brain keeps asking anyway. It keeps searching for certainty in a situation that's inherently uncertain. And each time you ask a what-if question, your amygdala responds. Because the question implies a threat. This creates a loop. You ask, what if? You feel anxious, you try to answer the question to reduce the anxiety, but you can't, so you ask again, and the anxiety continues. This is why reassurance doesn't work long-term for anxiety. If someone asks, "What if something bad happens?" and you say, "Nothing bad will happen," their brain immediately generates a new question. "But what if it does?" And you're back in the loop. The only way out of the what if loop is to stop trying to answer the questions, to recognize that they're unanswerable, to accept uncertainty rather than fight it. But that's incredibly difficult, because accepting uncertainty means tolerating discomfort. And the anxious brain is desperately trying to avoid discomfort. Fact 25. Anticipatory anxiety can be worse than the event itself. Have you ever been terrified about something, a presentation, a medical procedure, a difficult conversation, and then when it actually happened, it wasn't as bad as you feared? This is incredibly common, and it reveals something important about anxiety. The anticipation is often worse than the reality. When you're anticipating something, your brain generates every possible negative outcome. It catastrophizes. It imagines all the ways things could go wrong, and it responds to each imagined scenario with fear. But when the event actually happens, you're dealing with reality, not imagination. And reality, even when it's difficult, is finite. It's specific. You can respond to it. Anticipatory anxiety is diffuse. It's vague. It's all the possible bad things at once. And that's overwhelming. There's also a neurological reason for this. When you're anticipating something, your prefrontal cortex is active, running simulations. But you're not in action mode. You're not doing anything. So there's no outlet for the stress response. But when the event is actually happening, your body shifts into action mode. Adrenaline flows. Your focus narrows. You stop thinking about everything that could go wrong and start dealing with what is going wrong. And often, you discover you can handle it. This is why exposure therapy works. By actually facing the feared situation, rather than just imagining it, people often discover that their catastrophic predictions don't come true. And even when things are difficult, they survive. The anticipation created a monster. The reality is just a challenge. The addictive nature of fear. Fact 26. Fear and excitement are neurologically similar. Here's something paradoxical. Fear and excitement feel very similar. The physical sensations are nearly identical. Racing heart, rapid breathing, heightened alertness, sweaty palms. The difference isn't in the body's response. The difference is in how the brain interprets that response. When you're on a roller coaster, your body is in a state of high arousal. Your amygdala is active. Your sympathetic nervous system is engaged. But your prefrontal cortex is interpreting the situation as safe. You're not in danger. This is fun. So the arousal becomes excitement rather than fear. But the physiological state is the same. This is why people seek out thrilling experiences. Skydiving, bungee jumping, horror movies, haunted houses. They're voluntarily activating their fear system. And because they know they're safe, the fear becomes pleasurable. Psychologists call this benign masochism. It's the enjoyment of negative sensations in a safe context. And there's a neurochemical reason for this. When you're in a state of high arousal, whether from fear or excitement, your brain releases dopamine. Dopamine is associated with pleasure, motivation, and reward. It makes you feel good. So when you experience fear in a safe context, you get the rush of adrenaline plus the reward of dopamine. It's a powerful combination, and it can be addictive. This is why some people become adrenaline junkies, why they seek out increasingly intense experiences. Because the fear response, when it's safe, feels good. But this also explains why some people become addicted to anxiety. Their brain has learned to associate the state of high arousal with something important. And even though it's unpleasant, it's familiar. It's stimulating, and on some level, it feels necessary. Fact 27. Horror movies and fear entertainment exploit the amygdala. The horror movie industry exists because people voluntarily pay to be scared. And this seems counterintuitive. Why would anyone want to feel fear? The answer lies in the brain's inability to fully distinguish between real and simulated threats. When you watch a horror movie, your amygdala responds to the threatening images on screen. It doesn't matter that you know it's fiction. The visual and auditory cues, sudden movements, loud noises, threatening faces, dark environments trigger your fear response. Your heart rate increases. Your muscles tense. You might jump or scream. But at the same time, your prefrontal cortex knows you're safe. You're sitting in a theater or on your couch. Nothing can actually hurt you. This creates a unique psychological state. You're experiencing fear, but you're also experiencing safety. And that combination is exhilarating. There's also a sense of control. You can close your eyes. You can leave the theater. You can turn off the movie. The fear is optional. And that optional nature makes it tolerable, even enjoyable. Additionally, there's a social component. Watching horror movies with others creates shared emotional experiences. You bond over the fear. You laugh afterward about the parts that scared you. It becomes a story you tell. And there's a sense of accomplishment. You survived something scary. Even though it wasn't real, your brain still registers it as a challenge overcome. And that feels good. This is also why horror movies often have a resolution. The monster is defeated. The threat is eliminated. The characters survive. This provides catharsis. The fear is released, and you feel relief. Fact 28. Fear can become a habit. Your brain forms habits through repetition and reinforcement. When you do something repeatedly, the neural pathways associated with that behavior become stronger. It becomes automatic. Fear can work the same way. If you frequently think anxious thoughts, your brain strengthens the neural pathways associated with anxiety. If you frequently avoid situations that make you nervous, your brain learns that avoidance is the appropriate response. If you frequently interpret ambiguous situations as threatening, your brain becomes more likely to do so in the future. This is called neuroplasticity. Your brain physically changes based on how you use it. And this creates a vicious cycle. The more you experience fear, the more easily you experience fear. The more you worry, the more your brain defaults to worry. The more you avoid, the more anxiety you feel when you can't avoid. This is why anxiety disorders tend to worsen over time if left untreated. The fear response becomes habitual. It becomes the brain's default mode. But the good news is that neuroplasticity works in both directions. If you can interrupt the fear habit through therapy, through exposure, through mindfulness, you can weaken those pathways. And you can strengthen new pathways. Pathways associated with calm, with safety, with resilience. But it takes time, and it takes repetition. Because you're not just changing your thoughts, you're changing your brain. Fact 29. Fear releases dopamine, creating a reward cycle. Dopamine is often called the pleasure chemical, but that's not quite accurate. Dopamine is more about motivation and anticipation. It's released when you're pursuing a reward, not just when you achieve it. And here's the interesting part. Dopamine is also released during states of high arousal, including fear. When you're afraid, your brain enters a heightened state. Everything becomes more vivid, more intense, more significant, and dopamine is part of that process. It sharpens your focus. It increases your alertness. It makes the experience memorable. This is why traumatic events are often remembered in such vivid detail. The combination of fear and dopamine creates powerful, lasting memories. But dopamine also creates a reward association. If you experience fear and then relief, if you survive the threat, your brain registers that as a win, and it releases more dopamine. This is why people can become addicted to risky behavior. The fear activates the system. The survival creates the reward, and the brain wants to repeat the experience. It's also why some people struggle to break anxiety patterns. The anxiety feels bad, yes, but on a neurochemical level, it's also stimulating. It's activating, and the brain can become habituated to that state of arousal. This doesn't mean people are choosing to be anxious. It means their brain has learned to associate anxiety with alertness, with importance, with being prepared. And breaking that association requires retraining the brain. Fact 30. The fear of missing out, FOMO, is a modern fear response. FOMO, the fear of missing out, is a relatively new term, but the underlying fear is ancient. Humans are social animals. For most of our evolutionary history, being excluded from the group was life-threatening. If you're cast out of your tribe, You lost access to food, shelter, protection, and mates. Exclusion meant death. So the brain evolved to be extremely sensitive to social exclusion, and it responds to exclusion with fear. In the modern world, physical exclusion is rare, but social exclusion still happens. And with the rise of social media, we're constantly exposed to evidence of experiences we're not having, parties we weren't invited to, trips we're not taking, successes we haven't achieved. And each time you see evidence of something happening without you, your amygdala responds. Not dramatically, usually, just a low-level signal. You're being left out. Over time, this creates chronic anxiety. You feel like you're always missing something, always behind, always on the outside. And the modern environment makes this worse. Because social media is curated. People post their highlights, their best moments, their successes. They don't post the boring parts, the struggles, the failures. So when you compare your real life to other people's highlight reels, your brain perceives a threat. You're not keeping up. You're not succeeding. You're being left behind. And your brain responds with the same fear it would respond to actual social exclusion. Because to your amygdala, the feeling of being left out is the feeling of being in danger. This is why FOMO is so powerful. It's not shallow or trivial. It's a deeply rooted evolutionary fear being triggered by modern technology. Fear and decision-making. Fact 31. Fear narrows your focus to immediate threats. When the amygdala is active, your attention narrows. This is called attentional tunneling, and it's a survival mechanism. When you're in danger, you don't need to think about long-term goals. You don't need to consider multiple perspectives. You need to focus on the immediate threat and respond. So fear narrows your cognitive focus. It directs all your mental resources toward the source of the threat. Everything else fades into the background. This is adaptive in genuinely dangerous situations. If you're being chased by a predator, you need to focus entirely on escaping. Distractions could be fatal. But in the modern world, this narrowing of focus creates problems. Because most decisions require broad thinking. They require considering multiple factors, weighing pros and cons, thinking about long-term consequences. Fear prevents that. When you're afraid, you can only see the threat. You can't see opportunities. You can't see alternatives. You can't think creatively. This is why people make poor decisions when they're afraid. They choose the option that eliminates the immediate threat, even if it creates larger problems later. They avoid rather than engage. They react rather than respond. And this is especially problematic in high-stakes situations. Business decisions, relationship decisions, life choices. If you make these decisions while you're in a fear state, you're making them with a narrowed perspective, and you're likely to regret them later. Fact 32. Fear overrides logic and reasoning. The prefrontal cortex, the part of your brain responsible for logical thinking, is powerful, but it's not in charge when you're afraid. When the amygdala is activated, it can actually suppress activity in the prefrontal cortex. Neurologically, this happens through inhibitory connections. The amygdala sends signals that reduce the activity of the brain regions responsible for rational thought. This is why you can know, intellectually, that something is safe and still feel terrified. A person with a phobia of flying knows, statistically, that planes are safe. They understand the logic. But when they're on the plane, logic doesn't help, because their amygdala is overriding their prefrontal cortex. This is also why you can't reason someone out of fear. Telling someone there's nothing to be afraid of or you're being irrational doesn't work, because the fear isn't coming from the rational part of their brain. It's coming from the amygdala, and the amygdala doesn't speak the language of logic. The amygdala speaks the language of survival. And in the survival hierarchy, emotion beats reason every time. This is not a design flaw. This is intentional. Because in a life or death situation, overthinking can get you killed. You don't have time to carefully analyze all the options. You need to act, and fear makes you act. But in the modern world, where most threats are not life or death, this override is counterproductive. It makes you act impulsively. It makes you avoid things that would be good for you. It makes you say and do things you later regret. Understanding this can create compassion, both for yourself and for others. When someone is afraid, they're not being illogical on purpose. Their brain is literally preventing them from accessing their logical mind. Fact 33. Time perception changes during fear. When you're afraid, time seems to slow down. Moments feel stretched out. Everything happens in slow motion. This is a well-documented phenomenon, and it's caused by changes in how the brain processes information during high-stress situations. When the amygdala is activated, it signals to the brain that what's happening right now is important. It needs to be remembered. So the brain increases its recording rate. It captures more details, more sensory information, more memories. Later, when you recall that event, your brain has more information to process, more frames, so to speak. And that makes the experience feel like it lasted longer than it actually did. This is why car accidents seem to happen in slow motion. Why people report that my life flashed before my eyes. Their brain was in hyperdrive, capturing every detail. But in the moment, time doesn't actually slow down. What changes is how you're experiencing it. Your perception becomes more detailed, more vivid, more intense. This has a survival function. In a dangerous situation, noticing details can save your life. The more information you process, the better your chances of responding appropriately. But this altered time perception also contributes to the intensity of traumatic memories. Because the event is encoded with such detail, such vividness, it feels more significant, more real, more present. This is part of why PTSD is so debilitating. The traumatic memory isn't just a memory. It's a hyper-detailed, emotionally charged recording that the brain can replay with disturbing accuracy. Fact 34. Fear makes ambiguity intolerable. When you're in a calm state, you can handle ambiguity. You can tolerate not knowing. You can sit with uncertainty. But when you're afraid, ambiguity becomes intolerable. This is because fear is, by definition, about threat. And the brain needs to know, is there a threat or not? Where is it? How big is it? How should I respond? When the answers to these questions are unclear, the brain's threat detection system stays activated. It can't resolve. It can't move on. So it keeps searching for clarity. This is why anxious people often become obsessed with getting answers. They need to know. They need certainty. They ask questions repeatedly. They seek reassurance. They research compulsively. But ambiguity is inherent to life. Most situations don't have clear answers. Most futures are uncertain. And trying to eliminate all ambiguity is impossible. This creates a trap. The anxious brain demands certainty. Life offers ambiguity, and the gap between the two creates more anxiety. Research shows that people with anxiety disorders have a lower tolerance for uncertainty than the general population. Their brains interpret uncertainty as danger, and they'll go to great lengths to avoid it. This is why exposure to uncertainty, learning to tolerate not knowing, is a core component of anxiety treatment. Because you can't eliminate uncertainty, but you can change how your brain responds to it. Fact 35. Fear creates a sense of urgency. When you're afraid, everything feels urgent. You feel like you need to act now. You need to decide now. You need to fix the problem immediately. This sense of urgency is created by the stress hormones flooding your system. Adrenaline, in particular, creates a feeling of immediate pressure. It's preparing your body for action. And psychologically, that translates to urgency. This makes sense in a life or death situation. If a predator is chasing you, the threat is urgent. You need to respond immediately. But in most modern situations, the urgency is illusory. The problem isn't as time-sensitive as it feels. You have more time to think, to consider, to choose. But fear doesn't allow for that. It compresses your sense of time. It makes you feel like if you don't act right now, something terrible will happen. This is why people make impulsive decisions when they're afraid. They feel like they can't afford to wait. They can't afford to think it through. They need to act. And often, they later regret those decisions. Because the urgency was in their brain, not in the situation. This is especially true for social fears. If you're afraid of what someone thinks of you, You might feel like you need to explain yourself right now. You need to fix their perception immediately. But that urgency is driven by your amygdala, not by reality. Learning to recognize this false urgency, to pause, to breathe, to ask, is this actually urgent, or does it just feel urgent, is a crucial skill for managing fear. Fact 36. Fear makes risk feel larger than reward. When you're afraid, your brain becomes risk-averse. It becomes hyper-aware of what could go wrong and underweights what could go right. This is called negativity bias, and it's hardwired into the amygdala. From an evolutionary perspective, this makes sense. Missing a potential reward, a piece of fruit, a potential mate, is unfortunate but not fatal. But missing a potential threat, a predator, a poisonous plant can be deadly. So natural selection favored brains that paid more attention to negative information than positive information. Brains that overestimated risks and underestimated rewards. And this bias is still active in the modern brain. When you're making a decision and you're afraid, you focus on everything that could go wrong. The potential benefits fade into the background. This is why anxiety keeps people stuck. They want to change jobs, but they can only see the risks. They want to start a relationship, but they can only imagine rejection. They want to pursue a goal, but they can only think about failure. The rewards are real. The opportunities are real, but fear makes them invisible. And because the brain is wired to prioritize threats over rewards, overriding this bias requires conscious effort. You have to deliberately shift your focus. You have to force yourself to consider the potential upsides, not just the downsides. But when you're in a fear state, your brain resists this. Because to your amygdala, focusing on rewards feels dangerous. It feels like ignoring threats. And that's the one thing the amygdala will never allow. Childhood, conditioning, and inherited fear. Fact 37. Fear can be learned through observation. You don't need to experience something directly to become afraid of it. You can learn fear by watching others. This is called observational learning or social learning, and it's incredibly powerful. If a child sees their parent react with fear to dogs, the child is likely to develop a fear of dogs, even if they've never been bitten. If a child sees their sibling panic during a thunderstorm, they're more likely to become afraid of storms. The brain has specialized neurons called mirror neurons that activate when you watch someone else perform an action or express an emotion. These neurons allow you to simulate the other person's experience in your own mind. You feel, to some degree, what they're feeling. This is the basis of empathy, but it's also the basis of learned fear. When you see someone afraid, your mirror neurons activate. Your amygdala responds. And if the observed fear is intense enough or repeated enough, your brain forms its own fear association. You don't need to be hurt by the dog. You just need to see someone else be afraid of the dog. This has survival value. If you see a member of your group react with fear to something, it's safer to avoid that thing than to test it yourself. Social learning allows individuals to benefit from the experiences of others without having to experience danger directly. But it also means fear can be transmitted culturally, from parent to child, from peer to peer, from generation to generation. And this is especially true in childhood, when the brain is most plastic, most impressionable. The fears you observe and absorb as a child can stay with you for life. Fact 38. Parenting styles shape a child's fear response. Children aren't born with a fixed fear system. That system is shaped by experience, particularly by the way parents respond to the child's fear. If a parent consistently responds to a child's fear with comfort, reassurance, and calm problem solving, the child learns that fear is manageable. They learn that they can feel afraid and still be safe. They develop what psychologists call secure attachment. But if a parent responds to a child's fear with dismissal, "Stop crying, there's nothing to be afraid of, you're being ridiculous," the child learns that fear is unacceptable. They learn to suppress it. And often, that suppressed fear emerges later as anxiety. If a parent responds to a child's fear with their own fear, becoming anxious, overprotective, or panicked, the child learns that fear is dangerous, that the world is dangerous, and they become hypervigilant. And if a parent is the source of the fear, through abuse, neglect, or unpredictability, the child's fear system becomes deeply dysregulated. They develop what's called disorganized attachment, where the person who's supposed to be the source of safety is also the source of threat. This creates profound confusion in the developing brain. Research in developmental psychology shows that early attachment experiences literally shape the architecture of the brain. The connections between the amygdala and the prefrontal cortex, the sensitivity of the threat detection system, the ability to regulate emotions, all of these are influenced by how caregivers respond to a child's fear. This doesn't mean parents need to be perfect, but it does mean that how you respond to fear matters. Both your own fear and your child's fear. Because you're not just teaching them what to be afraid of. You're teaching them how to be afraid. Fact 39. Childhood trauma sensitizes the fear system permanently. Trauma during childhood has lasting effects on the brain's fear system. And the earlier the trauma, the more profound the impact. When a child experiences chronic fear through abuse, neglect, violence, or instability, their brain adapts. The amygdala becomes hyperreactive. The stress response system becomes hypersensitive. The connections between the amygdala and the prefrontal cortex weaken, making emotional regulation harder. This is the brain trying to survive. In a dangerous environment, being hypervigilant is adaptive. Being constantly on alert keeps you safe. But when that child grows up and leaves the dangerous environment, the brain doesn't automatically adjust. The fear system remains sensitized. The person continues to respond to the world as if it's dangerous, even when it's not. This is why adults who experience childhood trauma often struggle with anxiety, hypervigilance, and difficulty trusting others. It's not a character flaw. It's a nervous system that was trained through repeated experience to expect danger. And because this training happened during critical developmental periods, it's deeply embedded. The neural pathways are strong. The patterns are automatic. This doesn't mean they can't change. Neuroplasticity continues throughout life, but it means the change requires significant, sustained effort. Therapy, safe relationships, practices that retrain the nervous system. Understanding this can create profound compassion for people who struggle with anxiety and fear. Their brain isn't broken. It's adapted to survive the environment it grew up in. And now it needs to be gently retaught that the world can be safe. Fact 40. Fear responses can be passed down genetically. This sounds like science fiction, but it's real. Fear can be inherited. Research in a field called epigenetics has shown that traumatic experiences can alter gene expression in ways that are passed down to offspring. In a famous study, researchers exposed mice to a specific smell paired with an electric shock. The mice learned to fear that smell. But here's what was remarkable. The offspring of those mice, who had never been exposed to the shock, also showed a fear response to that same smell, as did the generation after that. The fear was inherited. This happens through chemical modifications to DNA called epigenetic marks. These marks don't change the DNA sequence itself, but they change how genes are expressed. And these marks can be passed from parent to child. In humans, research suggests that children and grandchildren of Holocaust survivors show altered stress responses. Children of people who lived through famine show metabolic changes. The trauma experienced by one generation can echo through the next. This is still an emerging field, and there's much we don't understand. But the implications are profound. It means that the fears and traumas of your ancestors might be living in your body, not just psychologically, through learned behavior, but biologically through inherited genetic patterns. This doesn't mean you're doomed to repeat the past, but it does mean that some of your fear responses might not be entirely your own. They might be inherited echoes of dangers your ancestors faced. Understanding this can bring a sense of perspective. Your anxiety might not be all in your head. It might be in your genes. Fact 41. Early life stress alters brain development. The first few years of life are critical for brain development. The brain is growing rapidly, forming trillions of neural connections, establishing the fundamental architecture that will last a lifetime. And during this period, the brain is extraordinarily sensitive to environment. Positive experiences, safety, love, nurturing, promote healthy development. Negative experiences, fear, stress, neglect, alter development. When a child experiences chronic stress, their body produces chronically elevated levels of cortisol, the primary stress hormone. And high levels of cortisol during development are toxic to the brain. Cortisol affects the hippocampus, impairing memory formation. It affects the prefrontal cortex, reducing executive function. And it enlarges the amygdala, making the fear response more sensitive. These changes are measurable. Brain scans of children who experienced early trauma show smaller hippocampi, reduced prefrontal cortex activity, and overactive amygdalae compared to children who grew up in safe, stable environments. And these changes persist into adulthood. Adults who experienced early childhood adversity are at significantly higher risk for anxiety disorders, depression, PTSD, and other mental health conditions. This is not destiny. The brain remains plastic. It can heal, but it means that early experiences matter enormously. They set the baseline for how the fear system functions. This is why pediatricians, psychologists, and child development experts emphasize the importance of early intervention. If a child is growing up in a fearful environment, the earlier that's addressed, the better. Because the longer the fear system is chronically activated during development, the harder it is to recalibrate later. Fact 42. Safe relationships can rewire a dysregulated fear system. Here's the hopeful counterpoint to the previous facts. While trauma can dysregulate the fear system, safe relationships can repair it. The brain is constantly adapting. And when you're in a consistent, safe, supportive relationship with a therapist, a partner, a friend, your nervous system begins to recalibrate. This happens through a process called co-regulation. When you're with someone who is calm, whose nervous system is regulated, their calm can influence your nervous system. You begin to match their state. Over time, with repeated experiences of safety, your brain forms new neural pathways. Your amygdala learns that not every situation is dangerous. Your prefrontal cortex strengthens its ability to regulate fear. Your stress response becomes less hair-trigger. This is the basis of many therapeutic approaches, particularly trauma therapy. The relationship between therapist and client is itself healing because it provides the safety that allows the nervous system to relax, to trust, to rebuild. This is also why healthy relationships are so important for mental health. They're not just nice to have, they're neurologically necessary. Humans are social animals. Our nervous systems are designed to be regulated by connection with others. When you're isolated, when you're alone, your fear system has no external regulation. It can spiral. But when you're connected, when you're with someone safe, your system can calm. This doesn't happen overnight. Rewiring a dysregulated fear system takes time. It takes consistency. It takes patience. But it's possible. The brain is not fixed. And fear, even deeply rooted fear, can be transformed. Modern fear and the civilized nervous system. Fact 43. Modern humans rarely face physical danger, but the fear system remains. For 99% of human evolutionary history, physical danger was common. Predators, rival groups, injury, starvation, exposure. But in the modern developed world, physical danger is statistically rare. You're unlikely to be attacked by a predator. You have access to food, shelter, medical care. You live in a world with laws, police, locked doors. You are safer than any generation of humans has ever been. But your brain doesn't know that. Your brain is still running the same threat detection software that was designed for a world full of physical dangers. And that software doesn't distinguish between ancient threats and modern challenges. So when you face a modern stressor, a deadline, a social conflict, financial pressure, your brain responds the same way it would respond to a lion. It activates the fear system. It floods you with stress hormones. It prepares you to fight or flee. Except there's nothing to fight, nothing to flee from. This is called the evolutionary mismatch. Your brain evolved for one environment. You live in a different one, and the two don't align. This mismatch is the root of much modern anxiety. You feel danger when there's no danger. You feel fear when you're safe. Because your internal alarm system is calibrated for a world that no longer exists. Fact 44. Social rejection activates the same neural pathways as physical pain. Being excluded, rejected, or socially isolated doesn't just hurt emotionally. It hurts neurologically in the same way physical pain hurts. Brain imaging studies show that social rejection activates the dorsal anterior cingulate cortex and the anterior insula, the same regions that process physical pain. This isn't metaphorical. When someone says rejection hurts, they're describing a real neurological experience. Why would the brain process social pain the same way as physical pain? Because for social animals like humans, social exclusion was a physical threat. If you're cast out of your group, you lost access to resources, protection, and reproduction. You were vulnerable. You were likely to die. So the brain evolved to treat social rejection as dangerous. It hurts so that you'll avoid it, so that you'll do what's necessary to maintain social bonds. This is why social fears are so powerful. The fear of being judged, the fear of embarrassment, the fear of rejection. These aren't trivial. They tap into a deep survival mechanism. And in the modern world, where social interactions are constant and often public, thanks to social media, the opportunities for social pain are endless. Every time you post something and no one likes it, your brain registers a small rejection. Every time you send a message and don't get a response, there's a tiny social pain. Every time you see others succeeding while you struggle, there's a feeling of being left behind. And your brain responds to all of it. Not dramatically, usually, but cumulatively, these small social pains add up. And they keep your fear system chronically activated. Fact 45. Financial fear is a modern proxy for survival fear. Money didn't exist for most of human history. But the fear of not having enough, the fear of scarcity, is ancient. For your ancestors, scarcity meant starvation. It meant vulnerability. It meant death. So the brain evolved to be extremely sensitive to resource scarcity. And in the modern world, money is the primary resource. It represents access to food, shelter, safety, healthcare, stability. When you don't have enough money, or when you fear you won't have enough, your amygdala interprets this as a survival threat. This is why financial stress is so physiologically damaging. It's not just worrying about numbers in a bank account. It's activating the same fear system that would activate if you were facing starvation. And because money is tied to nearly every aspect of modern life, financial fear is pervasive. It's background noise for millions of people, a constant, low-level activation of the threat detection system. Research shows that financial stress impairs cognitive function. It reduces IQ. It impairs decision-making. It increases impulsivity. Why? Because when the amygdala is activated by fear, it suppresses the prefrontal cortex. And when you're chronically worried about money, your prefrontal cortex is chronically suppressed. This creates a vicious cycle. Financial stress makes it harder to think clearly. Thinking poorly leads to worse financial decisions. Worse financial decisions increase financial stress. Understanding that financial fear is a survival fear, not a rational assessment, can help interrupt this cycle. Because the fear is real, but it's not always proportional to the actual threat. Fact 46. The fear of failure is a fear of social death. Failure, in the modern world, rarely leads to death. If you fail a test, you don't die. If you fail at a job, you don't die. If a business fails, you don't die. But it feels like you might. Because failure is socially consequential. It affects your status, your reputation, your opportunities. And in the social world of primates, status matters. Throughout human evolution, low social status meant reduced access to resources and mates. It meant being at the bottom of the hierarchy, vulnerable to exploitation and exclusion. So the brain evolved to fear failure because failure meant loss of status. And loss of status was a survival threat. In the modern world, this fear persists. People avoid trying new things because they're afraid of failing. They stay in unfulfilling jobs because leaving feels risky. They don't pursue goals because the possibility of failure feels unbearable. This is not laziness. This is not lack of ambition. This is the amygdala doing its job, protecting you from perceived social death. But here's the critical difference. In the modern world, failure is rarely permanent. You can fail and recover. You can fail and learn. You can fail and try again. But your brain doesn't naturally see it that way. Because in the ancestral environment, failure often didn't come with second chances. Overcoming the fear of failure requires retraining the brain, teaching it that failure is information, not death, that status is fluid, not fixed, that you can survive failure and even grow from it. But this requires repeatedly facing the fear. Because the only way to convince the amygdala that failure is safe is to fail, survive, and repeat. Fact 47. Perfectionism is a fear-driven behavior. Perfectionism is often praised. It's seen as a sign of high standards, of excellence, of caring about quality. But psychologically, perfectionism is a fear response. Perfectionists are afraid. They're afraid of making mistakes, afraid of being criticized, afraid of being seen as inadequate. And they cope with that fear by trying to be perfect. If I do everything perfectly, they think, then I'll be safe. I won't be criticized. I won't be rejected. I won't fail. But perfection is impossible, and the pursuit of it is exhausting. Perfectionism keeps the fear system chronically activated, because there's always something that could be better, always a mistake that could be made, always a way you could fall short. And when perfectionists inevitably do make mistakes, because everyone makes mistakes, they experience intense shame and self-criticism, which reinforces the fear, which drives them to try even harder to be perfect. This is a vicious cycle. Research shows that perfectionism is strongly linked to anxiety, depression, and burnout, because it's a strategy that never works. The fear is never resolved. The threat is never eliminated. Because the threat is internal, it's the fear of being imperfect in an imperfect world. Understanding perfectionism as a fear response can create compassion. For yourself, if you're a perfectionist. For others, if you see them struggling with it. Because the perfectionist isn't choosing to be rigid and self-critical. They're trying to survive. Their brain has learned that mistakes are dangerous, and they're doing everything they can to avoid danger. Healing perfectionism requires learning that mistakes are not dangerous, that you can be imperfect and still be safe, still be loved, still be enough. But that's a hard lesson for the amygdala to learn. Fact 48. The need for control is a response to fear. People who have a strong need for control are often afraid. They're afraid of uncertainty, afraid of things going wrong, afraid of being vulnerable or helpless. And they cope with that fear by trying to control everything. Their environment, their schedule, other people, outcomes. If I can control everything, they think, then nothing bad will happen. I'll be safe. But control is an illusion. Life is inherently uncontrollable. Other people have their own wills. Circumstances change. Unexpected things happen. And when a controlling person encounters something they can't control, their fear spikes. They become anxious, sometimes angry, because their primary coping mechanism, control, has failed. This is especially common in people who experience chaos or trauma earlier in life. If you grew up in an unpredictable environment, with an unstable parent, with abuse, with frequent moves or disruptions, your brain learned that unpredictability is dangerous. So as an adult, you try to create predictability. You try to control, because control feels like safety, but the cost is high. Relationships suffer. Flexibility disappears. And the underlying fear is never addressed. It's just managed. True safety doesn't come from controlling everything. It comes from building the internal capacity to handle uncertainty, to tolerate discomfort, to trust that you can adapt to whatever happens. But that requires letting go. And letting go feels terrifying to the fear-driven brain. Fact 49. Avoidance strengthens fear. When you're afraid of something, the natural impulse is to avoid it. If you're afraid of flying, you don't fly. If you're afraid of public speaking, you decline opportunities to speak. If you're afraid of rejection, you don't pursue relationships. In the short term, avoidance works. It reduces your fear. You feel relief. But in the long term, avoidance makes fear stronger. Here's why. When you avoid something, you never get the opportunity to learn that it's safe. Your brain never gets to update its threat assessment. The fear remains unchallenged, and often it grows. This is called negative reinforcement. The fear predicts danger. You avoid. Nothing bad happens. And your brain concludes, see, avoidance kept me safe. But the logic is flawed. Nothing bad happened because there was no real danger, not because you avoided it. Over time, the list of things you avoid grows. The fear generalizes, and your world becomes smaller. This is how phobias develop and persist. This is how social anxiety becomes debilitating. This is how agoraphobia can trap someone in their home. The only way to weaken fear is exposure. To face the feared situation, discover that you survive and allow your brain to update its threat assessment. This is the basis of exposure therapy, one of the most effective treatments for anxiety disorders. You gradually, systematically expose yourself to the thing you fear in a controlled way until your amygdala learns that it's not actually dangerous. But exposure is hard because it requires doing the thing that scares you. It requires feeling the fear and moving forward anyway. It requires courage. Fact 50. Hypervigilance is exhausting. Hypervigilance is a state of constant alertness. You're always scanning, always monitoring, always waiting for something to go wrong. It's common in people with anxiety, particularly those with trauma histories. Their threat detection system never turns off, and it's exhausting. Neurologically, hypervigilance means your amygdala is chronically active. Your sympathetic nervous system is chronically engaged. Your body is producing stress hormones constantly. This is supposed to be a short-term state. It evolved from moments of acute danger. But when it becomes chronic, it wreaks havoc on your body and mind. Chronic hypervigilance leads to fatigue, sleep problems, difficulty concentrating, irritability, muscle tension, headaches, digestive issues, because your body is running a marathon at sprint speed. People with hypervigilance often feel like they can't relax. Even in safe situations, even when they want to relax, their nervous system won't let them. They feel on edge, restless, unable to be fully present. This is because their brain has learned that the world is dangerous. And when you believe the world is dangerous, you can't afford to let your guard down. Healing hypervigilance requires retraining the nervous system, teaching it that it's okay to relax, that safety is possible, that not every moment requires vigilance. But this is a slow process, because the hypervigilance developed for a reason. It was adaptive once, and convincing the brain to abandon it requires repeated experiences of safety. Therapy, mindfulness, safe relationships, practices that activate the parasympathetic nervous system, the rest and digest system. Over time, the vigilance can soften. The nervous system can learn to rest, but it requires patience and compassion. Because hypervigilance is not a choice. It's a survival strategy that outstayed its usefulness. Fear, control, and manipulation. Fact 51. Fear is the most powerful tool for controlling behavior. If you want to control someone, make them afraid. This is not a new insight. It's been understood by leaders, governments, religions, and marketers for thousands of years. Fear makes people compliant. It makes them obedient. It makes them look for protection and accept authority. When people are afraid, their prefrontal cortex, the part of the brain responsible for critical thinking, is suppressed. They're less likely to question, less likely to resist, more likely to follow. This is why authoritarian regimes use fear. They create enemies. They exaggerate threats. They make people feel like they're in constant danger. And then they present themselves as the solution, the protector, the authority that can keep you safe. And it works because fear overrides reason. When you're afraid, you don't carefully evaluate whether the threat is real or whether the proposed solution is justified. You just want the fear to stop. This is also why fear is used in advertising. Fear of missing out, fear of being left behind, fear of aging, of being unattractive, of being inadequate. These fears sell products. And it's why fear is used in media. Fear attracts attention. Scary headlines get clicks. Threatening news gets views. Because the brain is wired to pay attention to threats. Understanding this doesn't make you immune, but it does give you a tool. When you notice fear being invoked in a political speech, in an advertisement, in a news story, you can ask, is this fear justified? Or is it being used to manipulate me? Fact 52. Fearful people are more likely to obey authority. Research in social psychology has consistently shown that fear increases obedience to authority. The famous Milgram experiment demonstrated that ordinary people would administer what they believed were dangerous electric shocks to another person, simply because an authority figure told them to. Why? Because fear makes you look for safety, and authority represents safety. Someone who's in charge. Someone who knows what to do. Someone who will protect you. When you're calm and secure, you can question authority. You can evaluate whether the authority's instructions make sense. You can resist, but when you're afraid, you defer. Because resistance feels risky, and in a fear state, risk is intolerable. This is why creating fear is a cornerstone of authoritarian control. Make people afraid, and they'll accept restrictions on their freedom. They'll tolerate surveillance. They'll turn on outsiders. They'll follow orders. Because fear makes uncertainty unbearable, and following authority eliminates uncertainty. This is deeply rooted in primate behavior. In social hierarchies, following the dominant individual keeps you safe. Challenging them is dangerous, and humans have inherited this. We have a built-in deference to authority, especially when we're afraid. Being aware of this tendency is crucial, because it means you need to be especially critical when you're afraid. You need to ask, am I agreeing with this because it makes sense? Or am I agreeing because I'm afraid and looking for someone to follow? Fact 53. News media uses fear because fear captures attention. The news media has a saying, if it bleeds, it leads. This means that stories about danger, violence, tragedy, and threat get the most attention. And attention is the currency of modern media. Why does fear capture attention so effectively? Because the amygdala prioritizes threatening information. When you're scrolling through headlines, your brain is scanning for threats. And when it detects one, dangerous virus spreading, economic collapse looming, crime wave in your city, it stops. It focuses. It pays attention. This isn't a conscious choice. It's automatic. And media companies know this. They're not trying to accurately represent the statistical frequency of events. They're trying to capture your attention. And fear does that better than almost anything else. The result is a distorted perception of reality. If you consume a lot of news, especially sensationalized news, you're likely to believe the world is more dangerous than it actually is. This is called mean world syndrome. People who watch a lot of television news tend to believe that crime is more common, that danger is more prevalent, and that people are less trustworthy than they actually are. Because the news doesn't show you the thousands of planes that landed safely. It shows you the one that crashed. It doesn't show you the millions of people who went about their day without incident. It shows you the violent crime. And your amygdala doesn't do statistics. It responds to the information it receives. And if that information is disproportionately threatening, your amygdala concludes that the world is threatening. Protecting yourself from this requires media literacy. It requires consuming news critically. It requires remembering that news is not a representative sample of reality. It's a curated selection designed to capture attention. Fact 54. Advertising exploits fear to sell products. Advertisers understand the brain's fear response, and they use it. Fear of aging, fear of being unattractive, fear of being inadequate, fear of being left out, fear of being unsafe. These fears are invoked, subtly or overtly, to sell products. You're afraid of aging? Buy this anti-aging cream. You're afraid of being unattractive? Buy these clothes, this makeup, this gym membership. You're afraid of being inadequate? Buy this car, this watch, this house. You're afraid of being left out? Buy this phone, this subscription, this experience. The formula is simple. Invoke fear, offer product as solution. And it works. Because when you're in a fear state, you're motivated to eliminate the threat. And if the ad suggests that the product will do that, your brain says, yes, I need that. This is especially insidious because most of the fears invoked by advertising are social fears. They're not about survival. They're about status, attractiveness, belonging. But your amygdala doesn't distinguish. Fear is fear. And because modern life is saturated with advertising on screens, billboards, podcasts, social media, you're being exposed to fear-based messaging constantly. Over time, this creates a baseline of insecurity. You feel like you're not enough. You feel like you need more. You feel like without the right products, you're somehow vulnerable. This is not an accident. It's intentional, and recognizing it is the first step toward resisting it. Fact 55. Social media algorithms amplify fear because it drives engagement. Social media platforms make money through engagement. The more time you spend on the platform, the more ads you see, the more money they make. And the algorithms that determine what you see are designed to maximize engagement. What kind of content maximizes engagement? Content that triggers strong emotions. Anger, outrage, fear. When you see something that makes you afraid or angry, you're more likely to click, to comment, to share. Because your amygdala is activated. And an activated amygdala demands attention. So the algorithm learns. It shows you more content that triggers fear. And the more you engage with that content, the more it shows you. This creates a feedback loop. You're exposed to more and more threatening content. Your perception of danger increases. Your anxiety increases. And you keep scrolling because your brain is trying to assess the threat. Research shows that social media use is correlated with increased anxiety, especially in young people. And it's not just because of social comparison, though that's part of it. It's because the content itself is designed to activate your threat detection system. The platform doesn't care whether the threats are real. It cares whether you stay engaged. And your amygdala can't tell the difference between a real threat and a curated algorithmic feed designed to exploit your fear response. Protecting yourself requires awareness. It requires recognizing when you're being manipulated. It requires taking breaks. It requires curating your feed intentionally, not passively consuming whatever the algorithm serves. Because the algorithm is not your friend. It's a profit-maximizing system, and fear is one of its most effective tools. Fact 56. Cults and manipulative groups use fear to maintain control. Cults and other high-control groups use fear systematically. They create fear of the outside world. Out there is dangerous. Only we can keep you safe. They create fear of leaving. If you leave, terrible things will happen to you. They create fear of questioning. Doubt is dangerous. Trust the leader. And they reinforce this fear through isolation, through information control, through peer pressure. When you're in a fear state, you're not thinking critically. You're looking for safety. And if the group positions itself as the only source of safety, you stay. Even when part of you knows something is wrong. This is not stupidity. This is not weakness. This is the amygdala doing what it evolved to do. Prioritize survival over everything else. And if the group has convinced you that leaving means danger, your amygdala will keep you there. Leaving a cult or high-control group requires overriding that fear. It requires having some external support, some outside perspective that can challenge the fear narrative. But as long as the person is isolated, as long as the fear is reinforced, escape is incredibly difficult. Understanding this is important not just for recognizing cults, but for recognizing any relationship or environment that uses fear to control. Ask, am I staying because I want to? Or am I staying because I'm afraid of what will happen if I leave? If the answer is fear, that's a red flag. Memory, imagination, and the fear loop. Fact 57. Fear memories are more vivid than ordinary memories. You can probably recall, in great detail, a moment when you were terrified. A cas accident, a frightening medical diagnosis, a moment of intense embarrassment or humiliation. But you probably can't recall, with the same clarity, what you had for lunch last Tuesday. Why? Because fear enhances memory encoding. When the amygdala is activated, it signals to the hippocampus, the memory center, that this experience is important. It needs to be remembered. And the stress hormones released during fear, particularly adrenaline and cortisol, chemically enhance memory consolidation. The result is a memory that's extraordinarily vivid. You remember the sights, the sounds, the smells, the sensations. You remember details you wouldn't normally notice. This is adaptive. If something nearly kills you, you need to remember it. You need to remember the context, the warning signs, the details, so you can avoid it in the future. But this also creates a problem, because fear memories don't fade the way ordinary memories do. They remain vivid. They remain emotionally charged, and they can be triggered easily. This is the basis of flashbacks in PTSD. The memory isn't just a memory. It's a vivid, emotionally intense re-experiencing. The person isn't just remembering the event. They're feeling it again, as if it's happening now, because the amygdala has encoded the memory with such strength that the line between past and present becomes blurred. Fact 58. Intrusive thoughts are the brain's attempt to process threats. Intrusive thoughts are unwanted, distressing thoughts that pop into your mind unbidden. They're common in anxiety and OCD, but most people experience them occasionally. What if I crash the car? What if I hurt someone? What if something terrible happens to my child? These thoughts feel disturbing, alien, like they come from somewhere outside yourself. But they're actually a misfiring of the brain's threat detection system. Your brain is constantly scanning for potential dangers. And part of that scanning involves imagining possible threats. This is perspective cognition, simulating the future to prepare for it. But in some people, particularly those with anxiety or OCD, this system becomes hyperactive. The brain generates threat scenarios constantly. And because the thoughts involve danger, they trigger the fear response. And here's where it gets tricky. When you have an intrusive thought and you react with fear, your brain interprets that fear as evidence that the thought is important, that it might be real. So it focuses on it more, which makes it more likely to recur. This creates a loop. Intrusive thought, fear, attention, more intrusive thoughts. And the more you try to suppress the thought, the more it returns. This is called the white bear effect. If I tell you, don't think about a white bear, what happens? You think about a white bear. The same mechanism applies to intrusive thoughts. The more you try not to think about the disturbing thought, the more your brain focuses on it. The solution is counterintuitive. Instead of fighting the thought, you acknowledge it. That's just my brain generating a threat scenario. It's not real. I don't need to respond to it. This takes practice. But over time, the brain learns that the thought isn't important, and the loop weakens. Fact 59. Imagination activates the same fear circuits as reality. Close your eyes and imagine you're standing on the edge of a cliff. Really visualize it. See the drop. Feel the wind. Notice the sensation in your body. Did your heart rate increase? Did you feel a flutter of fear? That's because your brain activated the same fear circuits it would activate if you were actually standing on a cliff. Your amygdala cannot fully distinguish between a vividly imagined threat and a real one. Both activate the same neural pathways. This is why visualization is powerful. Athletes use it to improve performance. Therapists use it to help clients rehearse difficult situations. But it's also why anxiety is so powerful. Because people with anxiety aren't just worrying. They're vividly imagining worst-case scenarios. And their brain is responding to those imagined scenarios as if they're real. Each time you imagine something going wrong, your amygdala responds. Your body responds. You feel fear. And that fear reinforces the neural pathway, making it easier for your brain to imagine the same scenario again. This is the imagination fear loop. Imagination, fear, reinforcement, more imagination. Breaking this loop requires recognizing that just because you can imagine something doesn't mean it's likely. Just because your brain generated a scary scenario doesn't mean you need to respond to it. But this requires conscious effort, because the default mode of the anxious brain is to treat imagination as prediction. Fact 60. Nightmares are fear processing during sleep. Most people have nightmares occasionally, but people with anxiety and trauma have them frequently. Why do we have nightmares? Current neuroscience suggests that nightmares are the brain's attempt to process fear and threat during sleep. During REM sleep, the brain is highly active. It's consolidating memories, integrating experiences, and, according to some theories, simulating threats to prepare for them. But when the threat simulation system is hyperactive, as it is in anxiety and PTSD, the simulations become intense. They become nightmares. Interestingly, the amygdala is active during REM sleep, but the prefrontal cortex, which regulates fear, is less active. This is why nightmares feel so vivid and uncontrollable. Your fear response is activated, but your ability to regulate it is diminished. For people with PTSD, nightmares often involve re-experiencing the traumatic event. The brain is trying to process the trauma, but because the memory is so strongly encoded, the processing is itself traumatic. This creates a vicious cycle. The trauma disrupts sleep. Poor sleep makes it harder to regulate emotions during the day. Poor emotional regulation increases anxiety. Increased anxiety leads to more nightmares. Treatment for trauma-related nightmares often involves a technique called imagery rehearsal therapy. The person rewrites the nightmare while awake, changing the ending to something neutral or positive. Then they rehearse the new version. Over time, the brain incorporates the new narrative, and the nightmares decrease. This works because nightmares aren't just random. They're patterns, and patterns can be changed. Fact 61. Rumination is a verbal form of hypervigilance. Rumination is repetitive, cyclical thinking about problems, fears, or past events. It's different from problem solving because it doesn't lead to resolution. It just goes in circles. Why did I say that? Why do I always mess things up? What's wrong with me? What if it happens again? People who ruminate often feel like they're trying to figure something out, but they're actually stuck in a loop. Neurologically, rumination involves both the amygdala and the default mode network, DMN, a set of brain regions that activate when you're not focused on the external world. The DMN is involved in self-referential thinking, thinking about yourself, your past, your future. And when the amygdala is also active, that self-referential thinking becomes threat-focused. You're not just thinking about yourself. You're scanning yourself for problems, for flaws, for threats. Rumination is essentially mental hypervigilance. You're monitoring your internal world the same way hypervigilance monitors the external world. And it's just as exhausting. Research shows that rumination is a major risk factor for depression and anxiety because it keeps the threat detection system activated. And it prevents you from being present, from engaging with the world, from experiencing positive emotions. Breaking the rumination cycle requires interrupting the pattern. Physical activity, social interaction, mindfulness, anything that shifts attention away from the internal loop. But this requires recognizing that you're ruminating, which can be hard because rumination feels important. It feels like you're working on something, but you're not. You're stuck. Fact 62. Flashbacks are the brain failing to recognize past versus present. In PTSD, flashbacks are a hallmark symptom. The person suddenly feels like the traumatic event is happening again, not just remembering it, re-experiencing it. Why does this happen? Normal memories are encoded with a timestamp. Your brain knows this happened in the past. There's a temporal distance. But traumatic memories are encoded differently. Because the amygdala was so intensely activated during the trauma, the memory is stored in a fragmented, disorganized way. And critically, it's not properly time-stamped. So when the memory is triggered by a smell, a sound, a situation, the brain doesn't recognize it as past. It feels present. This is why flashbacks are so distressing. The person isn't just remembering fear. They're feeling fear as if the threat is happening right now. Treatment for PTSD often involves helping the brain properly process and timestamp the traumatic memory. Therapies like EMDR, a movement desensitization and reprocessing, and trauma-focused CBT help the person revisit the memory in a safe context, allowing the brain to refile it as past rather than present. This doesn't erase the memory, but it changes how the memory is experienced. It becomes something that happened, rather than something that's happening. This is delicate work. It requires a skilled therapist and a safe environment, because the process involves activating the traumatic memory, which is intensely painful. But it's also profoundly healing, because it frees the person from being trapped in the past. Fact 63. The brain generalizes fear to similar situations. Once your brain learns to fear something, it often extends that fear to similar things. This is called fear generalization. If you were bitten by a German shepherd, you might become afraid of all large dogs. If you had a panic attack in a crowded mall, you might start avoiding all crowded spaces. If you were humiliated during a public presentation, you might become afraid of any public speaking. This happens because the brain is trying to keep you safe. If one situation was dangerous, similar situations might also be dangerous. So it's safer to avoid all of them. This is adaptive in some contexts. If one berry made you sick, it makes sense to avoid similar-looking berries. But in the modern world, this generalization often goes too far. The fear becomes overly broad, and your world becomes smaller. This is a major problem in anxiety disorders. The fear starts specific, fear of a particular dog, a particular situation, but it spreads, and eventually, the person is avoiding entire categories of experiences. Overcoming fear generalization requires discrimination learning. You need to teach your brain that not all similar situations are dangerous, that there are safe versions and unsafe versions. And you do this through careful, graduated exposure. But this is hard, because the brain's default is to be cautious. To assume similarity means danger. It takes repeated, consistent experiences of safety to convince the amygdala otherwise. Physical manifestations of fear. Fact 64. Chronic fear suppresses the immune system. Your immune system and your fear system are connected. And when the fear system is chronically activated, immune function suffers. This happens through stress hormones, particularly cortisol. In the short term, cortisol is helpful. It mobilizes energy, increases alertness, and temporarily boosts certain immune functions. But chronic cortisol elevation, which happens with chronic fear and anxiety, has the opposite effect. It suppresses immune function. It reduces the production of lymphocytes, white blood cells. It impairs the body's ability to fight infections. This is why people who are chronically stressed or anxious get sick more often. Their immune system is compromised. From an evolutionary perspective, this makes sense. If you're facing an immediate threat, a predator, an attack, your body doesn't need to worry about fighting off a cold. It needs all its resources focused on survival. So the immune system is temporarily suppressed. But in the modern world, where threats are chronic rather than acute, the immune system never gets the signal to turn back on, and the person becomes vulnerable to illness. This is one of the many ways that psychological fear creates physical consequences. Fact 65. The gut-brain axis means fear affects digestion. Have you ever felt nauseous before a stressful event? Or experienced diarrhea when you're nervous? That's the gut-brain axis in action. Your digestive system and your brain are connected through the vagus nerve and through chemical signaling. And when your amygdala is activated, it affects your gut. During a fear response, digestion slows or stops. Blood is redirected away from the digestive system to the muscles. The body doesn't want to waste energy digesting food when survival is at stake. This is why fear can cause nausea, stomach pain, diarrhea, or constipation. Your digestive system is responding to the threat signal from your brain. Chronic anxiety often leads to chronic digestive issues. Irritable bowel syndrome, IBS, is strongly linked to anxiety because the gut is constantly receiving fear signals from the brain. Interestingly, the relationship goes both ways. Your gut health can also affect your anxiety. The gut produces neurotransmitters, including serotonin, and gut bacteria influence brain function through the vagus nerve. This is why stress management often improves digestive symptoms, and why improving gut health can reduce anxiety. The mind and body are not separate. They're a unified system, and fear affects the whole system. Fact 66. Muscle tension from fear leads to chronic pain. When you're afraid, your muscles tense. This is preparation for action, for fighting or fleeing. But when fear is chronic, muscle tension becomes chronic. And chronic muscle tension leads to pain. Tension headaches, jaw pain from clenching, neck and shoulder pain, back pain. All of these are common in people with chronic anxiety. The muscles are constantly braced, constantly tight, never fully relaxing. And over time, this creates pain, fatigue, and sometimes injury. This is also why people with anxiety often feel physically exhausted. Their muscles are working even when they're sitting still. Releasing this tension requires more than just relaxing. It requires retraining the nervous system, teaching it that it's safe to let go. Practices like progressive muscle relaxation, yoga, massage, and somatic therapy can help because they work directly with the body, helping it learn what safety feels like. But this takes time. The tension didn't develop overnight, and it won't release overnight. Fact 67. Fear disrupts sleep architecture. Fear and sleep are antagonistic. You can't be asleep and vigilant at the same time. So when your fear system is activated, sleep suffers. People with anxiety often have difficulty falling asleep. They lie in bed, mind racing, body tense, because their amygdala is active and their brain interprets that activity as a signal that it's not safe to sleep. And even when they do fall asleep, the quality is poor. They wake frequently. They have nightmares. They don't spend enough time in deep, restorative sleep. This happens because the fear system and the sleep system are regulated by overlapping brain regions. When one is active, the other is suppressed. Chronic sleep disruption then worsens anxiety because sleep deprivation impairs prefrontal cortex function. And the prefrontal cortex is what regulates the amygdala. So poor sleep makes it harder to regulate fear, which increases anxiety, which disrupts sleep further. This is another vicious cycle. Improving sleep often requires addressing the underlying fear, calming the nervous system, creating a sense of safety. But it also requires good sleep hygiene, consistent sleep schedule, dark, quiet environment, limited screens before bed. Because even a calm nervous system needs the right conditions to sleep well. Fact 68. Chronic fear accelerates aging. Chronic stress and fear don't just affect how you feel. They affect how you age. Research on telomeres, the protective caps on the ends of chromosomes, shows that chronic stress shortens them. And shorter telomeres are associated with accelerated aging and increased risk of age-related diseases. Chronic cortisol elevation also affects the brain. It can shrink the hippocampus, impairing memory. It can accelerate the development of neurodegenerative diseases. And chronic inflammation, which is increased by chronic stress, is a risk factor for heart disease, diabetes, cancer, and other conditions. This doesn't mean fear is directly causing these diseases, but it is contributing to the biological processes that increase risk. From an evolutionary perspective, this makes a kind of sense. If you're living in a chronically dangerous environment, your body prioritizes short-term survival over long-term health. It doesn't invest in maintenance and repair. It invests in immediate defense. But in the modern world, this trade-off is harmful because the danger is psychological, and it doesn't end. Protecting your health requires managing fear, not just for your mental well-being, but for your physical longevity. The neuroscience of fear regulation. Fact 69. The prefrontal cortex can inhibit the amygdala. You're not helpless against fear. Your brain has a built-in regulation system. The prefrontal cortex, particularly a region called the ventromedial prefrontal cortex, VMPFC, has inhibitory connections to the amygdala. When the VMPFC is active, it can reduce amygdala activity. This is how you calm yourself down, how you override fear, how you think rationally even when you're scared. But this system requires activation. It requires conscious effort, and it requires practice. When you take a deep breath, pause, and tell yourself, I'm safe, this is just anxiety, you're activating your prefrontal cortex. You're engaging the regulatory system. And over time, with repeated practice, this pathway strengthens. It becomes easier to regulate fear. This is the basis of cognitive behavioral therapy, CBT. You learn to recognize fearful thoughts, challenge them, and replace them with more accurate thoughts. And in doing so, you're training your prefrontal cortex to regulate your amygdala. But it's not instant. The prefrontal cortex is slow. The amygdala is fast. So in moments of intense fear, the amygdala will win. But afterward, once the acute fear passes, the prefrontal cortex can step in and help you process what happened. This is why it's often useful to reflect on fearful experiences after they're over, to analyze them, to recognize what was real and what was exaggerated, because that reflection strengthens the regulatory pathway. Fact 70. Deep breathing activates the parasympathetic nervous system. One of the simplest, most effective tools for regulating fear is your breath. Slow, deep breathing activates the parasympathetic nervous system, the rest and digest system that counteracts the fight or flight system. When you breathe slowly and deeply, you stimulate the vagus nerve, which signals to the brain that you're safe. This reduces heart rate, lowers blood pressure, and decreases amygdala activity. This is why every anxiety management technique includes breathing exercises, because breath is a direct line to the nervous system, and it's something you can control. Even when everything else feels out of control, you can control your breath, but it requires doing it intentionally. Shallow, rapid breathing, which is common during anxiety, activates the sympathetic nervous system. It increases fear. Deep, slow breathing activates the parasympathetic system. It decreases fear. It sounds simple, and it is, but it's also powerful. The key is to make the exhale longer than the inhale. This is what activates the vagus nerve most effectively. Try it now. Breathe in for 4 counts. Breathe out for 6 counts. Notice the effect. Fact 71. Mindfulness reduces amygdala reactivity. Mindfulness, the practice of paying attention to the present moment without judgment, has measurable effects on the fear system. Research using brain imaging shows that people who practice mindfulness meditation have reduced amygdala reactivity. Their amygdala doesn't respond as strongly to threatening stimuli. Why? Because mindfulness trains the brain to observe thoughts and emotions without reacting to them. When you notice a fearful thought and simply observe it, there's a fear thought rather than getting caught up in it. You're engaging your prefrontal cortex. You're creating distance between the thought and your response. Over time, this changes the brain. The connections between the amygdala and the prefrontal cortex strengthen. The amygdala becomes less reactive. The person becomes less easily frightened. This doesn't mean the fear disappears. It means the relationship to fear changes. You feel fear, but you're not controlled by it. Mindfulness also teaches you to stay present. And fear is almost always about the future, anxiety, or the past trauma. When you're fully present, fear has less power. But mindfulness is a practice. It requires repetition. You can't meditate once and expect your amygdala to be permanently calm. You have to train the system over and over until the new pattern becomes default. Fact 72. Physical exercise reduces anxiety by metabolizing stress hormones. Exercise is one of the most effective treatments for anxiety, and it works through multiple mechanisms. First, exercise metabolizes stress hormones. When you're anxious, your body is flooded with adrenaline and cortisol. These hormones are preparing you for action. So when you actually take action, when you run, lift, move, you complete the stress cycle. The hormones are used, and your body can return a baseline. Second, exercise increases the production of endorphins and other neurotransmitters that improve mood. Third, exercise reduces muscle tension, which reduces the physical experience of anxiety. And fourth, exercise provides a sense of mastery and control, which counteracts the helplessness that often accompanies fear. Research shows that regular aerobic exercise is as effective as medication for many people with mild to moderate anxiety and depression. But it has to be regular. One workout won't fix chronic anxiety, but consistent exercise 3 to 5 times a week changes the nervous system over time. It also matters what kind of exercise. High-intensity exercise is particularly effective because it mimics the physiological arousal of fear. You're intentionally activating the sympathetic nervous system and then allowing it to calm down. This trains the system to be more flexible. But any movement is better than none. Walking, yoga, dancing, it all helps. Fact 73. Social connection calms the nervous system. Humans are social animals. And one of the most powerful ways to regulate fear is through connection with others. When you're with someone you trust, someone who is calm, your nervous system co-regulates. You begin to match their state. This is called social buffering, and it's been observed in many social species, including humans. A child who is scared will calm down when held by a parent. An anxious person will feel calmer talking to a trusted friend. Even being in the presence of a calm person can reduce your own anxiety. This happens through multiple pathways: mirror neurons, pheromones, tone of voice, body language. All of these communicate safety. And when your brain receives these safety signals, your amygdala calms. This is why isolation worsens anxiety. When you're alone, there's no external regulation. Your nervous system is left to its own devices. And if your default is fear, you stay in fear. But connection breaks that cycle. This is also why therapy works. Yes, therapists teach skills and help you process experiences. But the relationship itself is healing. Being with someone who is consistently calm, who doesn't react to your fear with their own fear, teaches your nervous system that safety is possible. This is deeply wired. For millions of years, being alone meant being vulnerable. Being with your group meant being safe. That wiring is still there, and it can be used to heal fear. The path forward. Fact 74. Understanding fear gives you power over it. Fear is not your enemy. It never was. Fear is a system. A very old, very sophisticated system designed to protect you. The problem is not that you feel fear. The problem is that the system is often miscalibrated. It's responding to threats that aren't there. It's activating when you're safe. But understanding this, really understanding it, changes everything. When you know why your heart is racing, when you understand that your amygdala is responding to a perceived threat rather than a real one, you have choices. You can pause. You can breathe. You can engage your prefrontal cortex. You can remind yourself, this is my fear system. It's trying to protect me, but I'm actually safe. This doesn't make the fear disappear instantly, but it changes your relationship to it. You're no longer controlled by fear. You're observing fear. You're working with it rather than being overwhelmed by it. And over time, this understanding rewires the system. Because each time you recognize fear for what it is and respond skillfully, you strengthen the regulatory pathways. You teach your brain that it can tolerate discomfort, that it can survive uncertainty, that it doesn't need to panic. Knowledge is power, not because it eliminates fear, but because it gives you tools to work with it. Fact 75. Fear loses power when you stop avoiding it. Avoidance is the short-term relief that creates long-term suffering. Every time you avoid something you're afraid of, you reinforce the fear. You tell your brain, that thing is dangerous. We were right to be afraid. But when you face the fear, when you do the thing you're afraid of and discover you survive, you weaken the fear. This is the principle behind exposure therapy. And it works, but it has to be done carefully. You can't just throw yourself into your worst fear and hope for the best. That can re-traumatize. Instead, you approach the fear gradually. You start small. You build tolerance. You allow your brain to learn, step by step, that the thing you're afraid of is not as dangerous as it feels. And with each successful exposure, the fear loses power. This is hard. It requires courage. It requires willingness to feel discomfort. But it's the only way through. Because fear doesn't dissolve in avoidance. It grows. But fear does dissolve in presence. In facing. In surviving. Fact 76. You are not your fear. This is perhaps the most important thing to understand. You are not your fear. You are not your anxiety. You are not your panic. These are experiences you're having. They're sensations in your body. They're thoughts in your mind. They're activations of your nervous system. But they are not you. You are the one who experiences them. You're the awareness that notices them. And that distinction matters. Because when you identify with your fear, when you think, I am anxious, I am broken, I am weak, you give the fear your identity. You make it who you are. But when you create separation, when you think, I am experiencing anxiety, I am noticing fear, my amygdala is activated, you reclaim your power. You're not the storm. You're the sky that the storm passes through. This perspective doesn't come naturally. It requires practice. It requires mindfulness. It requires consistently reminding yourself that thoughts and feelings are temporary experiences, not permanent identities. But it's liberating, because it means you can feel fear without being defined by it. You could be afraid and still be whole. Closing. Fear was never your enemy. It was your misunderstood messenger. A system designed to protect you, running in a world it was never designed for. And now you understand it. You understand why you feel fear when there's no danger. You understand why your brain treats imagined threats as real. You understand why anxiety persists even when you know, logically, that you're safe. You understand the amygdala, the way it bypasses your conscious mind, the way it floods your body with stress hormones, the way it narrows your focus and overrides your logic. You understand that fear is not weakness. It's not failure. It's not something to be ashamed of. It's biology. It's evolution. It's a survival system doing exactly what it was designed to do. And you understand that you're not helpless against it. You have a prefrontal cortex that can regulate. You have breath that can calm. You have the ability to observe, to pause, to choose how you respond. You have the power to face fear, to tolerate discomfort, to rewire the system over time. This knowledge doesn't erase fear, but it transforms your relationship to it. You're no longer at war with your own nervous system. You're working with it, understanding it, training it, and slowly, gently, fear loses its grip, not because you've conquered it, but because you've understood it. Fear was never the problem. The problem was not knowing why it was there. And now you know. If this resonated with you, if you found value in understanding the architecture of your own mind, subscribe. Because there's so much more to explore, so many more systems to understand, so many more ways to make sense of the human experience. Thank you for spending this time here, for going deep, for being willing to understand rather than just react. You're not your fear. You're the one who understands it. And that makes all the difference.